In this video, I will demonstrate how to generate the nth Fibonacci number using a non-recursive function in the Swift language. If you recall, the Fibonacci sequence is defined by the recurrence relation f sub n equals f sub n minus 1 plus f sub n minus 2, with the initial values f sub 0 equals 0 and f sub 1 equals 1. We'll start by opening up an Xcode project. I actually already have opened a new Xcode project here, and I'm just on the screen here to select what type of project. So we'll actually select a Mac OS command line tool, and that'll ask us for the language of choice. We're going to, of course, choose Swift. That's kind of the point of this, part of it anyways. And we'll call this, how about Fibonacci Swift. And when this opens up a new project in Xcode, it'll give us a main.swift file with a hello world message, and we can, if we want, we can go ahead and build this. Make sure it builds and that we're starting from something clean and functioning, well, functioning but not very functional. So it'll take a second. Yeah, here we go. So of course the project builds. We have our hello world message, but we're going to replace this code, and we're going to start by creating our actual generate Fibonacci function, or we can just call it genfib here, and we'll change the file, creating a genfib function, and it'll take an integer as its sole argument and return an array of integers, which will actually be our Fibonacci series. So let's go ahead and type some of this in here. We're going to return an array of int. Oh, and I left something out here too. This should be type int. And so there's the stub of our function. And inside this function, we want to create an array called fibarray, and we're going to load it with n ones. So the value of n that we pass in here, that's how many places, how many index positions we want to create in this array, and we're just going to populate it with ones right away. And we'll call this fibarray. And in Swift, we have a convenient way here to initialize this with ones. And of course, as we said, n number of ones. And so the reason we're going to do this is knowing that f sub 0 equals 0 and f sub 1 equals 1, we just really need to initialize the first two values of the fibarray with, for f1 and f2 being 1s, the contents of those positions being 1s, and we know that we have a way to initialize this array with all 1s. If we just initialize the whole array, when we actually get into the loop here in a second, you'll see we're only going to be looping through the index value of 2 through 10, or 1 less than n, and we're going to overwrite the rest of the 1s in that array. So if we know we need to initialize the first two values as 1, let's just initialize the whole array with 1s, and then we will, as we loop through, we'll be replacing the other values of the index 2 through n, or 1 less than n. And inside that loop, of course, what we're actually going to do is add the value inside n minus 1. In this case, we're using I as the index, but we're adding the value of the value of I minus 2 plus the value of I minus 1. So it'll look something like this. So let's put our index I equals fib array I minus 2 plus fib array I minus 1. And then all we have to do after that, after we're finished looping through that, is return that array of ints, or what we call fib array. And then from the actual main function, we will be calling this genfib function. First, we want to, for our purposes here, we'll just set a value of n that we can change as we go if we want to try some different number of Fibonacci sequence numbers here. But and then we're going to create a variable. We'll just call it fib equals, and it will equal the results of our call to that function, and we'll just pass it the value of n. And when we're done, we can print the contents of that out. So let's go ahead and run it. It should work if I've not made any errors here. And there we have our Fibonacci sequence n equals 10. And if you want to do something kind of interesting here, you can set a breakpoint inside the loop, and we'll go ahead and build it and run it in the debugger. And you'll see here the array is initialized with all ones. And as we single step through this loop, there's our first changed value. So the array index, the value of index 2 or at index 2 is now going to be the f sub n minus 1 plus the value of f sub n minus 2, which is the value of index 1 plus the value of index 0, and of course that gives us 2 here for the value or the contents of index 2. And then if we keep looping through this, single stepping through this array, we now have that value changed to 3. Now it's 5, and so on. And we can speed up the process here. And we now have our complete array of ints that we're going to return. And if we go ahead and execute the rest of that, we're printing out our Fibonacci sequence for n equals 10. So I hope you find this video informative, interesting, helpful, any or all of those things, and thanks for watching.